Okay, I've been asked to review a couple of the problems from Exam 1. So the best way I think I could do this is to actually walk through the solution to each of these. First of all, number 3 is asking you to do partial fraction decomposition. So let me do my best to try and walk you through this. You start out with your rational expression. You notice that the denominator has a difference of squares and it's squared. So what I'll do is I'll do my difference of squares, which is x plus 5 times x minus 5, and then I'll square each one of those factors because of the squared out here. Then, since each of these factors is linear, x plus 5 and x minus 5, what I'll do is I will put a constant a over that linear factor, and then because it's squared, I have to do another constant b over that linear factor squared. And then I do the same thing for the other linear factor, a c over x minus 5, and then a d over x minus 5 squared. Okay, now if you take the, let me do it this way. If you take the denominator here and you multiply both sides of this equation right here by that denominator, on the left side everything cancels, all you get is 25. On the right side, what happens is, let's say for this first term, you multiply that by this denominator. Then one of the x plus 5's cancels, and what you're left with is an x plus 5 and then an x minus 5 squared. So that is this right here. And then when you do the same thing on the second term, you get an x plus 5 that cancels, x plus 5 squared that cancels, and what you're left with is the x minus 5 squared. So that's what you get here. Then you do the rest, the next two terms, and you get this whole thing over here. All right, now what I do, and I'm not showing this work, is I actually multiply out. I figure out what this is. That's x squared minus 10x plus 25. And then I multiply it by x plus 5, so I distribute the x through. Then I distribute the 5 through. And I get this monster-looking thing. It's actually this. When I collect all the like terms, I get that. And then I do the same thing on this one. I get this. And I do the same thing here. I get this. Actually, it goes out to there. And then these right here give me these last three terms. Then what I do is I collect all my like terms together. So I get all my x cubed terms together. Here's an x cubed. Here's an x cubed. So I put those out front here, collect them. And I get my x squareds here, 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 here. Put those here. I've color-coded them. Then my x terms. Then all my terms without any x's in them. Then I take the first two terms. I factor out an x cubed, and that leaves me with an a plus c in front. On the second group here, I factor out an x squared. I get this. The third group, I factor out an x. I get this. And then all those things without x's, I just leave them here. And then what I realize is that the left-hand side of the equation is 25. It's just a constant. That means it doesn't have any x cubes here. So there's no x, sorry about that. There are no x cubes. In other words, I could write it as there's really like a 0x cubed over here. And because of that, I know that the two numbers in front here, or the a and the c here, those must be equal to the 0 that would be in front of the x cubed on the left. So I write a plus c is 0. For the same reason, all this stuff in front of x squared, since there is no x squared over here, that means all those have to add up to be 0. So that's my second equation. Then I do the same thing for the third. There's no x term, so that has to add to be 0. And then the last thing is that all these things without x's at the end, that's just all adds up to be a number. And that has to match what's on the left side, so it has to be equal to 25. So that's where I get this last equation from. Okay, now let's work with these four equations. The first one tells me I can move the c to the other side. I know that a must be negative c. On the second equation, what I do is I replace, let me undo that. I replace my a here with negative c. Negative 5 times negative c is positive 5c, right there. And then I just rewrite the rest of the equation. I collect my 5c and 5c together here to give me 10c. Then I have my b, and I have my d, and I know that it equals 0. I'll get back to that. On the next equation, again, I replace my a here with negative c. Negative 25 times negative c gives me positive 25c. And notice that it cancels with the negative 25c here, and that leaves me with this equation here. If I divide both sides by 10, I move the d to the other side, or move the negative b to the other side, I get b must equal d. All right, the last equation, again, I replace my a here with negative c. That gives me this. And then I put that together with negative 25c. That gives me negative 250c. I put my 25d and 25d together, get 50d, then equals 25. Divide everything by 25, I get this. So now what I'm going to do is I'm going to take this equation here and this equation here, and I'm going to create a system of equations. That's what's down here on the bottom left, right here. And notice that if I write the two out and I just add straight down, the c's will cancel, which is good. Then I get 4d here, and then over here on the last one I get 1. Since 4d equals 1, I solve for d by dividing both sides by 4. I find out that d is 1/4. Now remember up here we said d was equal to b, so that means that b is also 1/4. Also, taking this equation, whoa. Sorry about that. My computer's acting funny. Taking this equation here, rewriting it, and replacing my d here with 1/4, I can solve this equation for c. And once I do that, I get this, multiply, get 1/2, move it to the other side, divide both sides by 10. I get c is negative 20. But remember up here, where was it? Right. Where was that thing? Here it is. A is negative c. So if I come down here, if I know what c is, then a is the opposite as far as sign. So a is 120. And now I just go back up and I replace everything up here. My a, talking about the top left here, my a, b, and c, a, b, c, and d, replace them with what we just found. I get a, b, c, and d, and then those simplify to be these things right here. And that's it. So that's the first question that was asked. That's number 3. Hope that makes sense. All right, for number 4, what we have is a linear factor in the denominator, so I put a constant over that linear factor. Then I have an irreducible quadratic, so I can't factor that. So, and it's squared. So what I'm going to do is I'm going to have to put a linear factor on top, bx plus c, over that quadratic, irreducible quadratic, and then another linear factor, dx plus e, over that irreducible quadratic factor squared. And then I do the same thing I did earlier. I take the denominator on the left, I multiply both sides. The left side is 4. The right side, when I multiply the a over x by that common denominator, the x cancels, and I'm left with the x squared plus 3 quantity squared, then times the a. I do that for all 3, and when I do that, I get this whole thing. And then doing like what we did before, multiply that all out, which I did here. Once you multiply that out, group all your like terms together. So here are my x to the 4th terms, my x cubed terms, my x squared terms, my x terms. And I might lose that here. My x terms, and then my terms that don't have any x's. I match that up with the left side. Since there are no x to the 4th terms on the left, I know that a plus b has to be 0. Since there are no x cubed terms, I know that the c must be 0. Since there are no x squared terms, I know that all of the stuff in front of x has to be 0. And then since there's no x terms on the left side, this 3c plus e must be 0. And then this is the critical one. 9a is a number, and it must match the number on the left. That means 9a must be 4. That means a must be 4/9. Now, I can come back up here to the first equation. If I move things over, I get b is negative a. But I know what a is, so b is the opposite of a. That's this. And then I know that c is 0. That's just already solved. I can use this equation here. I know what a is. I know what b is, so I can get d. So I plug in the a. I plug in what we found for b. Multiply those out, add, and then what I get over here is that d is equal to negative 4/3. Okay, and then finally here, this 3c plus e equals 0. I know c is 0 already, so that kills that off, and that means e is 0. Plugging everything back into up here, you get this right here. All right, so that's number 4. Now I'm going to move on and I'm going to look at number 6 here. 6 is pretty quick. First of all, for number 6, we're asked to find the focus and directrix. What you're looking at here is y squared equals 6x. This looks like this form right here, y squared equals 4ax. So what I'm going to try and do is determine what the a is. So I know that the number in front of x is my 4a, and according to what I'm given in this problem, that must be 6. So that, dividing both sides by 4, I get a is 3/2. Now the focus of this parabola is the point a, 0, but I know a is 3/2, so it's just 3/2, 0. Now my directrix is the equation of the line x equals negative a. And since, again, I know what a is, it's just x equals negative, or opposite of what I have for a, so negative 3/2. So that's it. Really, that problem just comes down to figuring out what a is. Now, number 8 is a little more involved. Number 8, you're given a parabola. What you need to notice is that this parabola, since it's squared in y, this parabola opens either left or right. And because we have a negative in front here of the y squared, this should open to the left. So it's going to look like this. And if you go and look in your book, or look on the e-book, you'll see that the general formula for a parabola that opens to the left is this. And what we need to identify is k, a, and h. So to do this, we're going to have to complete the square. So first thing I do is I rearrange the right-hand side so it's in descending order. I take the first 2 terms here, and I factor out a negative 5. And I leave the negative 136 by itself. Once I factor out the negative 5, I take the y squared minus 12y, I take it over here, and I complete the square. So to complete the square, you take the coefficient of y, which is negative 12, you divide by 2, which gives you negative 6. You take that negative 6, you square it, you get 36. Now what you do with that is you take your problem the way it appeared, and right next to the negative 12y, you're going to take that number 36, you're going to add and subtract it. Now if you do that, the first 3 terms are guaranteed to factor as a perfect square. So you'll get this, y minus 6 squared. But you still have the negative 36 here, so you got to bring that down. Now I'm going to distribute my 5 through here and here. I get negative 5. Negative 5 to the first one there gives you that, and then negative 5 times positive 36 gives you 180. Then I still have the negative 136 out there. Put these 2 together, you get 44. Now, still trying to get it to look like this one up here, what I need to do is I need to get my y minus k squared by itself. So I need to try and get this thing by itself. So I subtract 44 on both sides. Okay. Now I divide through by negative 5, which really turns into a negative 5th out front. And now I'm saying to myself, look, this negative 1/5 has to match up to this negative 4a in the general formula. So that's why I wrote this down here. And now just solve for a. I divide both sides by negative 4. When you divide both sides by negative 4, you get a is 1 over 20, positive 1 over 20. So that means here's my general formula. I'm pretty much there. I know what h is. Okay, h is here. It's the opposite of what I see. So if it's negative 44, h is 44. And same thing with k, opposite of what I see. If it's negative 6, then k is positive 6. So the vertex is the point 44, 6. The focus is h minus a. And remember, I know what a is. A is 1 over 20. So I take the 44, I subtract 120. That gives me 879 over 20. So I have to get a common denominator to do that. And then my k is just 6, so I just leave it. So that's my focus. And then my directrix is just x equals h plus a this time. So 44 plus 120, and then again, common denominator, and you get this. All right. I know I'm moving fast through this, but I'm hoping it's helping here. I think the last one, I believe this is the last one, yeah. Trying to find the graph this ellipse by, locate the foci or foci. I hear it said different ways. So what we need to first realize is that the general equation of an ellipse is this here. So I'm going to take my equation. First thing I'm going to try and do is get get all my x squareds and y squareds on one side. So I move that to the left, which gives me this. And now I need a 1 on the right side, so I need to get rid of 21. The only way to get rid of 21 is to divide and make it a 1, is to divide by 21. So I divide both sides by 21. When I do that, I get this, this, and this. And now 3 over 21 reduces. You get a 7 here, 3 there. And then now you need to realize that in this formula, the denominator, that number is a squared, right? So we're saying, let's say here, 7 is our a squared, which means a is equal to square root of 7. And I know it's plus or minus, but a is always a positive number and b is always a positive number, so we only look at the positive case here. So I put that here and here to kind of stress that. That means a is root 7, b is root 3. And we notice that a is bigger than b. That means this is a horizontal ellipse, which means it opens up more like that, not like this. Okay, and now we identify some things here. The foci are the points plus or minus c, 0. But c comes from this equation, which again is given to you. And if you move things around here, you can solve for c, which means that it's just a squared minus b squared. A squared was 7, b squared was 3. Subtract, you get 4. Square root of that is plus or minus 2. So we get 2 here, and then of course the 0 just comes from here. So your foci are the points 2 and negative 2. Now to graph this, all you have to do is, like let x be 0. If you let x be 0, you can figure out what y is. If you let y be 0, you can figure out what x is. You can plot some points and draw your ellipse. Or you can just look at the picture online and try and match up the one that best fits what you have here. Okay, hope that helps.